Hi everyone, so in today's video we're going to have a look at environmental issues to do with second year revision, so going over what we did last year and looking at some exam practice. So what do you need to know? So a recap from last year, so that was the 6 R's and how they became applied to the design and manufacture of a product, the different labelling that can appear on products and what they mean, what a carbon footprint is, and to be able to give an example of carbon footprint for a real life product. And you need to be able to give real life examples of how companies are aiming to reduce the environmental impact that they're having. So just to put this in perspective of why this matters, obviously earth resources, things like oil, timber, metal ores, they're being consumed at a very, very fast rate. Timbers can't be replaced, they can be replaced, but they can't be replaced fast enough at the current rate of consumption we're doing now. The process of converting raw materials, such as things like crude oil, into products consumed a huge amount of energy. It's like things like big factories and that sort of thing. That creates a huge amount of CO2 emissions, which are then linked to things like global warming. The warming of the atmosphere creates unnatural changes in weather patterns, which can have devastating effects. Think like melting of the ice caps, raising sea levels, that sort of thing. And then when products are disposed of, they often go into landfill with waste resources and creates other environmental hazards that go along with that as well. So next thing, so look at the 6 R's and recycling. So the 6 R's I'm sure is nothing new to anyone. Things like rethink, refuse, reduce, reuse, recycle, replace. We won't go into each one individually, but they're quite self-explanatory. Things like reduce, so reducing the amount of materials used or the amount of packaging that something might be used for. Reusing, so if you're done with something, donating it or selling it on, that type of thing. Recycle, making sure things, instead of just chucking it away, it's recycled. Replace, so maybe making sure instead of so much breaking it a new one, replace certain parts of it because it's more sustainable way of doing it that way. So then with recycling, there's sort of 3 tiers to recycling. You've got primary recycling, with the use of functioning second-hand products, so chairs, tables, clothing, anything that's still like toys, donating it to charity shops, selling it on eBay, Gumtree, giving it to friends, that type of thing. Next, you've got secondary recycling, so that's when the product reaches the end of its life. The materials are then recycled to make different products, so boat sails are made for seats, plastic drink bottles can make plant pots, that type of thing. And then tertiary recycling, where you completely break down the product with a chemical process. So a big example of that is like drinks bottles, where they're shredded and spun into fibres, and then those fibres can make clothing. So in terms of some environmental legislation, like laws and regulations that are in place, so you've got eco-labelling, which is a voluntary scheme, so you don't have to sign up for it as a company, but it is quite a good thing to do. So this came in 1993. So this label, basically, if you've got, say, your product and you've got 3 or 4 similar products from different companies, this is what will make your product stand out as having the least negative effect on the environment as possible over its entire life cycle. So remember, the life cycle, that is actually from raw materials to extraction, to the manufacture of the product, all the way to being transported to the shop, to you buying it, to it then being used until it breaks or you no longer use it, and then you throw it away and it gets recycled or it goes in the landfill. That is what the whole idea of the product life cycle is. Okay, it's not just being used, it's that entire from raw materials all the way to disposal as well. You then got the packaging directive. So this was amended in 2004. So this sets targets for companies that reduces the amount of packaging waste by designing out how much packaging they have, or like making sure it can be recycled or making sure it can be reused. It also limits the amount of toxic material that can be used in packaging. And then you got the energy labeling directive, So we have looked at this before. So this is where you've got A to G, and this is so on all energy appliances you can see how energy efficient something is. So if something is very energy efficient, think like a light bulb. So when a light bulb's been on, if it's quite warm, like you touch it, it's very hot, that means it's not very energy efficient. And the reason that matters as a consumer, because the whole point of this, as it says there, is to discourage customers from buying them, like the poor ones. Say if you've got like a fridge and it's an A, and then you've got another fridge and it's an F, plug them in for the same amount of time, the electricity bill will be a lot higher for the F than the A because it is very bad. It has to use more energy to do the same sort of job. So it's there basically to help you as a consumer make a better choice and thus have less of a negative effect on the environment. You've then got end of life vehicle directive, which is a very hard thing to say quickly. So the aim of this is to encourage the reuse and recycling of waste from vehicles when they reach the end of their life. So not just completely like scrapping it, actually having some materials taken out, reused, that sort of thing. Restricts the use of toxic materials in new cars and requires manufacturers to clearly label plastic parts, making recycling more convenient. So, and we'll talk about that again in the WEEE directive in a second, but that is if you've got parts, making sure that they're easy to take apart so that you can separate. So say if you've got components inside a casing and the components can't be recycled but the casing can, making it so the components can be taken out easily so that the casing can be recycled. Because in the past what will just happen is it will be stuck together in a way that it can't be reopened again, and what would happen is it have to just get chucked away. So if you can make it so the easier you can make things be taken apart, it then means the easier it is to be recycled, and you can encourage people to do it. A company that's quite bad at that is Apple. Even with their most recent phone, the iPhone 4222 or whatever it is, they are notoriously quite bad at letting it be that things can be taken apart and repaired or recycled, because they want to just buy a new phone because it's more money to them. So the idea is encourage, and like what you need to try and do is make it so that things can be taken apart. Okay, not all the electronic parts can be recycled, but that casing can be, that tray can be, that card can be. So make it so you can get in there and take those parts out. So then that leads nicely onto the WEEE directive, the Waste Electrical and Electronic Equipment Directive. So that encourages the development of electronic products that can be dismantled and the parts reused or recycled. So as I just said, some things inside components won't be able to be recycled. That's fine. But other parts can be. So rather than just go, oh, okay, this can't be, and just chucking everything, making it so you can take it apart and take the components out. It also then forces manufacturers to inform through their products that electronic devices should not be discarded, but instead taken to a WEEE collection point. Most of those for you will be recycling like tips like at the dump. Basically saying you shouldn't just be chucking your phones in the bin, your printers in the bin, your microwaves, that sort of thing. They should be disposed of properly so that they can be recycled and used properly. You've then got restriction of hazardous substances, the RoHS directive. Again, something we've looked at before. So this bans the use of some hazardous material and chemicals, things like lead, mercury, cadmium in electronics and electronic equipment. The whole point for this is to safeguard human health when electrical equipment is disposed of and recycled. Again, another reason why you can't just chuck it in bins and throw it on landfills, because it will release gases and that's going to cause like poison. So in terms of design approaches that companies can take to sort of have a positive effect, not a positive effect on the environment, that's probably the wrong way of saying it, but the least negative effect as possible. So think of it as like tiers, like tier 1, tier 2, tier 3. So entry level tier, like tier 1, green design. This will focus only on a couple of areas of the product's life cycle. So modifications such as conserving materials through using recycled materials in the manufacturing process, or by conserving energy in the use of product, are examples of green approach. So basically you're not going to do the whole process, but you'll just make sure, okay, we are using recycled materials for that, or our packaging, we're not using huge amounts. So then you're making a bit of an effort, but you definitely could do more. Next, you've got Ecodesign. So this design goes further than the green design, in that designers and manufacturers will collaborate to reduce the environmental impact of a product through the entire life cycle, and that is from extraction of raw materials all the way to disposal at end of life. Ecodesign aims to tackle environmental concerns such as materials consumption, fossil fuel consumption, and pollution / toxic waste. When developing a new product, an eco-design-oriented company would consider aspects such as the selection of their materials, reducing the amount of materials needed, reducing the impact of the product would have during use, and making sure that it is recyclable and will be used efficiently. And then the top tier one will be sustainable design. So this not only does everything that green design and eco design does, so they look at things like their materials, manufacturing processes, and that sort of thing. They also look at the wider picture of things as well, so the socio-economic issues, like the welfare of workers, so like things like fair trade schemes, making sure that sweatshops aren't used. Again, I feel like I'm picking an apple a little bit here, but there was a company in China where they made Apple products, and it had a very, very high suicide rate in there because the working conditions were so high pressured. So actually it was known for being terribly bad, because most people that worked there did end up sadly taking their own lives, which obviously is a terrible, terrible tragedy, and that just shows how poorly they're not really thinking about the other socio-economic issues around that. It might be, for example, if you're extracting raw materials and you're not considering the fact that there are people that live in a town or a village near that area, those sorts of things. So sustainable design will consider all those types of things, ensure workers are getting good conditions, they're getting good pay, that type of thing. So most resources are invested into analysing the function of a product and seeking more environmentally friendly methods of achieving the same function. So that might well be that now there's a product, and then maybe 2-3 years time, a new material gets developed, or the new manufacturing method gets developed to make the same thing. So they might then redesign the whole approach, going, actually, we used to make it out of this material, but we've just made this new polymer, we've made this new material that is better for the environment, and we can make it easier. So let's do it that way. And that's trying to figure out different, better ways of doing the same thing that already exists. So recycling labelling, we've all seen the polymer recycling codes, 1 to 7, 1 being really good, 7 being absolutely terrible. Things like on your plastic bottle, like water bottles, milk bottles, to styrofoam, like fast food containers, safety goggles, those sort of things. And then what you might not have remembered, some of the other recycling ones are things like glass, aluminium, steel. Just remember that the triangle itself is actually called a Mobius loop. So don't refer to it as environmental logo in your exam, because that's quite a GCSE answer and you wouldn't get the marks. It would be the Mobius loop. So carbon footprint. So we talked a little bit before about the product life cycle. So that is from raw materials, extraction, refining into a material being turned into something else, like into a physical product. That all falls under the carbon footprint. So take any product, for example. So we take getting the raw materials, so extracting it from the earth, so the amount of energy used to get it out of the earth or wherever it is, like from under the sea or whatever it may be, transporting that to a factory. In that factory, then refining that raw material into the actual physical material that we want, whether that is plastic or whatever it may be. Then transportation to another factory, wherever, and then turning that material into the physical product. Then that physical product being shipped to wherever in the world it may be, whether it is locally or whether it is abroad, being transported to a shop. Then from that shop, you going to that shop, whether you drove or wherever it may be, and then buying it and then taking it home. Then the whole point of you using it for however long you have it for, whether it's like something quite a long life, and then it being disposed of at the end of it. All of that is part of the carbon footprint, every single thing. So all the energy used to get the materials, the petrol used to do that, the energy used in the factory, the petrol you use to go and drive to the shop, the energy you use when you plug it in at home, and then every single thing like that falls under the carbon footprint. And some things can have quite good carbon footprints, quite small, and some can have quite big ones. Obviously, if you're buying something from, say, like China, that's going to have quite a large carbon footprint. So really, that's why when you see things now, it might say that resources have all been sourced locally. That means it's got quite a good footprint because it's all done like from this country, so you know it's not travelled huge miles, that sort of thing. So eco-design. So the whole idea behind eco-design, so that is using materials which have a low impact on the environment, reduce the amount of materials that you actually physically need, reduce the impact of distribution, so making sure that you're not sending things worldwide, it's like done like locally. Reducing energy consumption while it's being used, so making sure that it's not like really bad energy efficiency. Optimizing the product's lifetime, so making sure that it doesn't break earlier than it needs to do. And then optimizing the end of life, so making sure it's easier to be taken apart, to be recycled, and that type of thing. So landfills. Now we all heard the term landfill before. Essentially, it's just a dumping, like dig a big hole, dump everything you want in there. What you might not know is what happens is, once they're full, they're then covered with soil. Because of that, there's then a limited amount of oxygen and water available. That then makes the condition what's called anaerobic. And what that does is that stops oxygen and water getting into it. And that makes the rate of degradation, the rate it breaks down, a lot slower. Because it needs that water, it needs that oxygen to break down. So there are instances where like discarded food's been found in landfill sites years after it's been thrown away, when normally it should just break down naturally quite quickly. So things that some companies are doing that you might notice now to sort of have improve their effect on the environment, so things like reducing the size of the packaging to a minimum. I'm sure you may have ordering things like Amazon or start buying things from shops, comes in big boxes, you open it up and it turns out the thing inside the box is not even like a third of the size of the whole box. Making sure packaging typically is like rectangular shapes, so this makes transportation more efficient, therefore reducing the carbon footprint emitted by transport vehicles. What that means essentially is making sure the reason why they like packaging sizes are all uniform is that you can stack them and you can get more of them. So rather than say having 2 or 3 lorries to deliver things, because they don't stack and you can't fit so many into a lorry, having them so they can be stacked a lot better, so you can put them all in one lorry, so then you're only paying fuel for one lorry. That's the same theory behind why you have like Coke cans can all be stacked up nice and easily and those sort of things. But that's why you don't have really weird cardboard box shapes, because then it just becomes really inefficient. The use of LDPE cushions, so that is replacing essentially what was the styrofoam padding that you used to have in packaging. You still see it a little bit, but like the little peanut type things. So the LDPE cushions are just those like little air pockets that you put in, and it just stops your things wrapping around and breaking it. And you see it quite a lot now. If anyone ever ordered things like MyProtein or that type of thing, they're in it quite a lot, and they need to stab them, get the air out, and they can be recycled nice and easy because LDPE can be recycled. Using easily recyclable material, things like cardboard, because we know cardboard can be recycled, broken down, made more cardboard, no problem. Reducing the number of materials used to simplify recycling, so not coating more material on top of other material, not mixing materials together, because that makes it a lot more difficult to recycle. Then avoiding oil-based plastics if possible, or substitute with suitable biodegradable plastics, because they are now becoming a lot more used. Things like PLA. Anyone that's really into 3D printing now, you can buy a lot of like PLA because that is really easy to recycle. So other general developments. So we've just talked about inflatable LDPE cushions, things like LEDs. So the reason they're preferred over normal light is because they use about 90% less energy. They do not have anywhere near as much toxic material while they're being produced, and they have a much longer lifetime. So it means that they become a lot cheaper to manufacture. So that's why LEDs now, if you get like things done in your house, or the bathrooms and kitchens and new lighting, they're all LED lights, because it's just, they last longer, they're easier to make, they like are less toxic, everything like that, just much better. And then obviously energy ratings that you've got on there, so making sure things are labelled properly on there so that you can make good judgments. Now I've got an article here I just want to quickly show you. So if I go to this one, so this was from 2019, so just over a year. So Waitrose was one of the first. Other shops have started doing it now as well. But what they did, so if I just give you a basic overview of it, it was things like consumable ones that you can refill, things like coffee, cereal, nuts, dried fruit, that sort of thing. Rather than buy it and get the packets of it, if you can take like jars and other containers, you take that and then you can refill as much as you want or need. Now obviously what you do is you'd weigh your container first, so you know how much it weighs to begin with. Then you'd fill it up with, say, cornflakes or whatever it is, and then you'd reweigh it and you go, okay, I've got 900 grams of cornflakes in here, and that's what you'd pay for. So the idea is it's trying to replace the idea of just the throwaway culture of extra packaging. On top of that, obviously we have things like the bags for life and the carry bag tax, the plastic bag tax, that sort of thing. So all these sorts of things are things that are going on to discourage, maybe that's the wrong way, like encourage us to be more environmentally aware. So we're going to have a look at some questions now. So environmental issues, it's probably going to be some of the longer mark questions, 6 and above probably, maybe even like multiple part questions. So we'll have a look through, have a go at some questions. So first one, food packaging can have a negative effect on the environment. Explain how this can be minimised. You may use diagrams to support your answer. So 6 marks. So that's 3 points with an explanation. Just remember, if it's saying, oh, you can use diagrams, what it's saying is use diagrams. All right. So 6 marks. Pause the video, have a go at answering it, and I'll go for the answers. Okay. So what you could do, so reduce the thickness of the polymer to reduce the rate. So basically, rather than having really thick material like plastic of, say, whatever it may be, just having like half the size of it. Ensure that polymer is embossed with the recycling information, so having the Mobius loop with a number in it so it can be resorted easier. Using biodegradable polymers for the packaging so it can break down in landfills easier. Replace with paper-based packaging, so you're just not using plastic at all, you can have paper-based. Replace with reusable or refillable containers. that we talked about with the Waitrose, where you had like the jars you can refill. So anything around that would be absolutely fine. So evaluate the environmental issues associated with the use of polymers such as polyvinyl chloride, PVC. Again, 6 marks. So it's asking you to evaluate. So it wants good and bad points. So mark scheme is 6 marks. So you want 3 good points and 3 bad points to like summarize what you're trying to say. Pause the video, have a go at answering it, give yourself 6 minutes, and then we'll have go through the answers. Okay, so as it says there, so this is taken from the mark scheme, you want positives and negatives. So positive issues could be PVC is thermoplastic, so it can recycle into the ice, no problem. Thermoplastics have a long shelf life, so they will work for quite a long time without breaking down. These are thermoplastics that benefit manufacturers, so it's easier to manufacture with them. They meet eco legislation for manufacturing. Negative environments may be that PVC comes from crude oil, so that's a non-renewable source, so obviously that means once it's done, it's done. Crude oil extraction can cause damage to seabeds and marine habitats. Crude oil can be spilled. Think things like the BP oil spillage that happened 5-ish years ago, that sort of thing. Crude oil spillage is biohazard. So any landfills, so sitting in landfills and that sort of thing. So 3 positives and 3 negatives. That's what they were after there. So next one, analyse and evaluate the impact of die casting on the environment. So total 6 marks. So asking to analyse, so it wants good and bad points again. 6 marks, 3 good points, 3 bad points. You'll need to summarise or conclude as well, because it's asking you to evaluate. So 6 marks, pause the video, have an answer in, we'll go through. So waste material created during die casting can be recycled back into the process, so you can keep using it over and again, just melt it down and reuse it. Use from waste heat from die casting can be used to heat the factory, so that reduces the amount of energy used to require to heat it all up. Die casting is a process that uses a lot of energy, so it does have quite a high carbon footprint. Die casting can produce quite harmful gases. To cool the dies, water systems are often used. That water is usually extruded from like local water sources like rivers and that sort of thing, and purified on site, so that can reduce water levels locally. Die casting foundries take up a huge amount of space, so it does then have like, say, they probably had to cut down some land to build up this factory, so they may have like bothered like animal habitats, that sort of thing. And then modern furnaces to melt metal quickly with minimal heat loss from the furnace. This reduces the energy required and reduces the carbon emissions produced. So 3 positives and 3 negatives. That is the end of environmental issues and sustainable issues revision. If you've got any questions, send me a message on Teams or over email.